All right, so we're back into median properties. And so here we go, some median properties. All right, and so again, here's the first one. This is something a little bit new. A median divides the area of a triangle in half. All right, so these are equal areas over here. So that's our first property. All right, that's gonna come into play here in several different ways. And the three medians of a triangle meet at one point. This is something we looked at 9:30 today. That point is called your centroid. So that is right there. That's our centroid right there. All right, and then here's a different one. Here's our third property. On each median, the centroid is twice as far from the vertex as it is from the midpoint of the opposite side. That's pretty wordy. So when you've got your centroid here, which they call O, all right, and this distance here is twice as big as my blue line. All right, so those are three properties, specifically two of them, the first one and the third one, because we dealt with this second one earlier today. And we're going to do some questions, just kind of how it works. All right, so let's check it out. Here's a couple of examples. Given triangle ABC, all right, where 0 is the centroid, if the area of ABC is 56 meters squared, find the area of triangle ABM. All right, so actually ABM. All right, so I'm going to draw this. So I have triangle ABC here. All right, and the M is referring to the midpoint. All right, we'll get to that. All right, so let's see here. So I'm going to draw in my medians, sketch. So there's one median. Again, over to, that's a terrible line. I'm going to redraw that. All right, and again, I'm going to call this M. That's our midpoint right there. And let's see here. We got another line for our other median. There we go. And so our centroid is right here, again, called point 0. And it's saying the area of this entire triangle is 56 meters squared. And what we're looking for is the area of the triangle ABM. So I'm going to, the pink triangle. And again, that comes down to, and I'm going to refer to this, I'm going to go to my first sheet. A median divides our triangle in half. And so in this example that we have half the triangle. And so if I want to find the area, the area of triangle AB, I don't know how I'm going to put a triangle there, but we'll go with ABC, or ABM, sorry. It is going to equal half of triangle ABC, which is, let me extend this out, 56 meters squared. So if I take half of 56 meters squared, so again, that would be 0.5. So again, a decimal is just a division question that's not done yet. All right, so I take half of 56, and if I type that into my calculator, I believe I get 28. And again, that would be meters squared. Whoops, I don't like that pen. There we go. Meters squared. All right, so that's an easy one. Again, just using the first property. We're going to get a little tougher here. Nothing too crazy. All right, example 2. Given triangle DEF. So I'm going to draw a diagram here of triangle DEF. So we got D, E, just labeling it here, F. So there's my vertices. All right, now the midpoint, EMF. All right, so I'm looking at the midpoint between E and F. That's point M. I'm just going to draw you the diagram here of what I got going on. I want to find the area of DEF. All right, so again, my centroid, if I was to draw it in, which I will here, so we'll draw real quick a sketch. I use red lines here. There we go. A little bit of a creativeness there. All right, and so what this is saying is if the area of EMF, so, whoops, did I draw this right? I got my F. Oh, I want my midpoint, sorry. M is actually right here. Hopefully I can erase that. I can. Beautiful. All right. And so my area that I'm looking at, this is way easier to do on the smartboard, I'll tell you that, folks. EMF, so from, what is going on here? E to D. I've got my M. Yeah, my F's over here. All right, I'm going to start again here, folks. I'm going to erase this. I got messed up here. There we go. All right, so again, I got my triangle D to F, D, E, F. All right, and so I'm going to draw in just a median from F, because we don't have the centroid here. All right, so there's my median right there. D, E, or EMF. Again, I'm going to put M right here. There's my midpoint. There we go. That's a little bit better. It's a little clearer now. All right, so EMF is this triangle in purple. All right, and I'm saying that is 50 meters squared. And because that is half of the triangle, again, because the median cuts a triangle in half, the area of the entire triangle, so it's basically the reverse of what we just did, is going to be double that. So 2 times 50 meters squared, which of course 2 times 50 is 100. And again, that's just using the property that the median cuts our triangle in half. So half of it's 50, then the whole thing will be 100. All right, so let's try another one. Again, this is way easier to do on the smartboard. All right, so again, I have a triangle here. GHI is where 0 is the centroid, and the area of GHI is 180. Find the area of OMG. All right, so again, I'm going to draw this in here. I'm going to take my time here so I don't mess it up. So I got G, H, and I. Okay. The midpoint I'm looking at is between G and H. So right there, there's my M. All right, and I'm going to draw in a midpoint here because there it is. All right, and I want to know the area of OMG. Well, O is, again, the centroid. So I am going to have to draw in all the medians, a sketch of it anyways. So this one's a little harder here. So we got more lines. Again, my purple dot, I'm just going to put a big O in there. There's our centroid. All right, now, so this is telling me the area of the entire triangle is 180. And I want to find the area of OMG. So OM to G. All right, so again, O is my centroid to M to G. So I connect that triangle. All right, now, what happens here is a median cuts the triangle in half. But if you have all the medians, what happens is your triangle gets cut into 4, 5, 6 equal pieces. So all this piece here is 1/6 of 180. So if I take 80 and divide it into 6 pieces, that will be the area of area 1. That would be the area of area 2, area 3, area 4, area 5, and area 6. So again, the area of the area OMG is because all the medians are drawn in there. I take my 180, and all those medians, again, cut our triangle into 6 equal pieces. And so if I take 180 and divide it by 6, I get 30. So that's not just the halves, is that all the medians will cut our triangle into 6 different pieces. All right, so that's a little something different. All right, now that's using up property number 1. And again, we already did property number 2 about how all the medians meet at the centroid. So we guess we've worked on that too. All right, but now we're going to look at some of the lengths. All right,
I have a question.
Sure, go ahead. Whoops.
How do you know which point to draw the median from?
This is me drawing in a diagram for you. So in all the homework, the diagrams will already be drawn for you.
Okay.
Okay, and the M is always going to be your midpoint. That's key too. Your M will always be your midpoint. So this could be M. This could be M right here. So it might say HOM. That's what they would be talking about. Again, it's always been a lot easier to show on a smartboard here. All right, let's try, what do we got here? Another one here. All right, so this is using our third property again. Now, this is triangle DEF. So again, I take my time here. DEF. All right, so it's O is the centroid. So again, I'm going to have to draw in my medians, sketch. And to answer that last question there, right, I'll draw my M's. So I got to have like 3 different M's here. Midpoint, midpoint, and midpoint. All right, now again, this is my centroid right here, right? This is where 3 medians meet. And it is saying D to O. All right, so I'm going to draw that in blue. I'm going to find D to O. All right, O to M. So that'd be my centroid to this M right here. Because we're talking about D to O and O to M. So they got to be on the same line here. Now, this entire line, here's a trick here. This entire line has a length of 57. So the entire line, both the blue and the green line, have a length of 57. Now, I know because of that third property, if we go back, that the area, the blue line is twice as big as the green line, all right? So the blue line is 2 times bigger than the green line, which means that from D to M, we have 3 parts. 2 are the blue line, 1 are the O to M line, the green line here. So here's what I'm going to do. I'm going to take 57, and I'm going to cut it into 3 parts. All right, so I take 57, divide it into 3 parts. Excuse me. All right, I need my calculator. Grab 57, divide by 3. It's 19. All right, so that is telling me that one of the parts here is 19. So the one part here is 19. Now, because D to 0, or D to the O, which is the centroid, is 2 parts, I have to multiply that 19 by 2. And so this blue line would have a length of 2 times 19, which I believe is 38. So D to the centroid has a length of 38, and centroid to M has a length of 19. So again, the whole median can be cut into 3 parts because the blue line is twice as big as the green line. Is there any questions about that? That's a little bit tricky there. All right, I think I might have skipped an example, or maybe not. All right, let's try another one of those guys, I think. All right, triangle ABC. So, and then 0 again is the centroid. All right, so here we go. So I'm going to draw A, there's B, and there's C. All right, again, I'm going to draw in my medians. So estimating here, it's just a sketch, especially the way I draw lines, this mouse. Whoa, that one's off the beaten path there, so let's back that up. Okay, let's try this again from this side. All right, so again, here's an M, that's a midpoint. Here's an M, that's a midpoint. Here's an M, that's a midpoint. And there's my 0 right there. All right, so now all I'm doing here is drawing in the numbers. All right, so now it says if O to M, so the centroid to M, okay, so which one? Because there's 3 of them, right? But we're looking for B to O. So essentially here, I'm focused on the blue line here. Now, it says that O to M here is 14. So could somebody tell me what B to O would be then, or how I would find it? How would I find B to O, or B to the centroid, I guess, if I know that M to O is just 14?
Multiply 14 by 2?
Yeah, because the B to O, the vertex to the centroid, is twice as big. And so, yeah, I would find B to O. So let's see if I can draw that in here. B to O is equal to 2 times that because it's twice as big, which of course then means that it's going to be 28 centimeters. So that's the unit I had there. And there we go. All right, see, and that's it. Short one today. Let me